Okay, we're given set A. Now a set is a collection of items, a collection of elements. The set in number one, for number one, we're given that the universal set, a big U, is the 10 digits that we use in our number system. That's the universal set. That means that's everything we can possibly consider for problem one. Those are the things under consideration. It's the total universe of our possible sets for problems in this context are the digits from 0 to 9. There's 10 of them. Set A is the first 5 counting numbers. So what's not in A would be 0, 6, 7, 8, 9. This is what's called the complement of A. So that word complement, coming back to you, a different meaning than complementary angles, but they're adding up to the whole thing again. Complementary angles add up to 9 degrees, the whole thing being a right angle. Complementary sets add up to the entire universal set. So this is set A. I didn't write on the paper. You might want to add to your paper. I'm working right off of this practice only sheet, right? We're on the same sheet, right? So what's not in A was that. Set B is 4, 5, 6, 7. So what's not in B? Who's up next, Jordan?
Oh, Josie.
Josie, what's not in B?
0, 1, 2, 3, 8, and 9.
And you don't necessarily have to write that out, but you need to know that's the complement of B. The complement of B. What's not in B? You'll also see the notation sometimes B prime. Prime. A little apostrophe pronounced prime.
Oh, that's
like
the same.
prime B. Okay? These are the same. B prime and B naught. They're complement of B. There's a lot of different notations for this set theory stuff. Some authors will put a little C there for complement. A little C for the complement. Okay, and then we have C and we have D. As on your sheet, you should be able to figure out the complement of C and the complement of D. And then they start asking some questions. Okay? So, one more for Josephine. Part A. They want A union B. Do you happen to know what that is? What A union B is? Does anyone know what A union B is, Joe?
It's the A, all the numbers in A and B combined.
So, what would it be?
1, 2, 3, 4, 5, 6, 7.
6, 7. Okay? An element X, it's an element of A union B if and only if X is an element of A or X is an element of B. Now, these notes are online, but I'm thinking I might print out a few pages of these set theory notes because you really haven't seen much of this before. You just make sure that you have them to look at in class.
Which was it?
You might want to write this down.
And then that's for what now?
That's in the chapter 1-2 notes. This is just an explanation of what union of sets means. Union is when you put things together. Intersection is when you take what's in both of them. So to be in the intersection of two sets, X has to be an element of A and X is an element of B. So we've been dealing with this with some of our number line problems because we've had answers that had to be like less than 2 and greater than -3. And it was the intersection. Look at that. But X is less than 2 and X is greater than -3. Here's 2. We had all those forever. Here's -3. We have all these forever. But when I have the and, what works? Only this. It was the intersection. The and means intersection. -3 less or equal to X is less or equal to 2. So this and is really an upside down U. It looks like an intersection. So we actually have U for union and N for intersection. You get it?
Yes. Wait.
U for union and N for intersection. You know, you're stretching it just a bit.
Is that another, or is top two like X, E, or union?
This is
Is that
E.
another way of
This
writing
E is an element of. Now, what makes this hard is that for many of you, you haven't seen this kind of symbols before. But I bet in middle school, you guys dealt with unions and intersections before. Okay? So we're doing it again. Okay? So part A, Joe was right. A union B is 1, 2, 3, 4, 5, 6, 7 because we needed anything that was in A or was in B. It had to be in A or it had to be in B. So we had those 5, these 4, 4 and 5 matched up. So we just had 1 through 7. Part B, as I hoped, A intersection B. Josephine, can you get that?
Yeah, there would be 4 and 5.
Excellent. We need the intersection. We need what's in both of them. We need 4 and 5. If we had the whole universal set represented by this box, I could draw a circle for A, a circle for B. And they both have 4 and 5 in it, 4, 5. So A also has 1, 2, 3. And B also has 6 and 7. So there's A, there's B. So the union is those all together. The intersection is what they share. Anyone know what this kind of diagram is called?
Venn diagram.
Venn diagram. Named after a mathematician, last name Venn. Venn diagram. Sometimes we put more than 2 sets into the Venn diagram. So you've dealt with a lot of this stuff before, okay? So let's look at C union D. Jordan?
Oh, that was Ruthie.
Ruthie, can you look at the paper and tell me what C union D would be?
1, 3, 5, 6, 7, 8, 9.
She said 1, 3, 5, 6, 7, 8, 9. That's absolutely correct. Okay, and Ruthie, what would C intersect D be? Part D.
There are them.
Say that again.
There are any others.
No numbers. Does anyone know what we write when there's no numbers?
Empty set.
Empty set. So C intersection D is an empty set. That's one way to write it,
That's literally it.
but you guys know that that symbol means empty set. Null set, empty set. Null set, void set, empty set. But it is good to know that you can just make a set and make it empty.
Those are called brackets, right?
Those are brackets. We typically use brackets in order, curly Q brackets, in order to designate the elements of the set. Okay? And you guys need to do that on the homework paper. When it's a set, you need to put the brackets around it. And you might not be real good at it, but you know, some people will just cheat and do that. That's not bad. Try to make it curly Q, but it doesn't have to be as perfect as mine. Okay, I mean, I know that curly Q you can do that kind of work.
Now, make a point.
All right, who's up next, Jordan? Harrison, part E. They want the complement of A union the complement of B. You might need to look up there because we have, or you might have in your paper, the complement of A written down, the complement of B written down. What's the union?
It's a set of 0, 8, 9.
I disagree. I think you just did the complement of A intersect the complement of B. Do you want the intersection? This is a union. A union, everyone's involved in a union. Everyone's invited. Everyone in A is in it, everyone in B is in it. But the intersection is the special people who are both in A, in this case in the complement of A and in the complement of B. So when you said 0, 8, 9,
That was the intersection.
you were giving me the intersection. So what's the union?
0, no, what is it? 1, 2, 3?
More. Look right here. In order to be in the union of 2 sets, you just have to be in one or in the other. You don't have to be both. Are you wearing a blue shirt or green polka dotted pants? Are you? Are you wearing a blue shirt or green polka dotted pants? True or false? Harrison is wearing a blue shirt or Harrison is wearing green polka dotted pants.
True.
It's true. You don't have to have both of them true. It's an or. One or the other is true. So what works?
So it's 0 to 9, not including 4 and 5.
That's one way to say it. You know what he said? He said 0 to 9, take away 4 and 5. That's another thing we can do with sets. We have a subtraction, difference of sets. We took away. And if you do this and you take away the 4 or 5, you get that. That's the correct answer.
So you can write that for an answer on your homework.
We probably want to simplify this and go that way. But this could be an intermediate step. It could definitely be an intermediate step. Okay? Now, they didn't ask us for this one, but we did it. All right? So I'm going to come back up here to the front. And we're going to do another one. Pretty tough one. Who's up next, Jordan?
Okay.
You? That's awesome. Okay.
Wait, Mr. Paper,
Yes.
does it make a difference when the line is over the whole thing?
Yes, it does in a huge way. We're about to do that. Part F. We have A intersect B. Did I call that F? I didn't. I didn't. It looked like I did, but I didn't. But we've done the intersection. Now we're doing what's not in the intersection of A and B. So we have to do this first. So reminder, A intersection B was what, Jordan? What was A intersection B?
A intersection B is 1, 2, 3, 4, 5, 6, 7.
That's A union B. What's A intersection B? It's the set with 4 and 5. Okay, so Jordan, what's the complement of A intersection B?
1, 2, 3, 6, 7, 8, 9.
Almost. You missed one.
Wait, what are you doing right now?
0.
Is it union or intersection?
0.
He doing the intersection.
I'm doing the complement
of the-
of the intersection, A intersect B. This was A intersect B, it was 4 and 5. Jordan, what was missing?
0.
0. You guys follow that?
Wait, that's the intersection. Why do you have so many numbers?
Because this is the intersection, 4, 5. Do you agree?
Yeah.
This is the complement of the intersection. It's what's not in the intersection of A and B. So we want all the people who are not wearing blue shirts and wearing green polka dotted pants. Okay.
And how is that different?
So is the complement of A intersection B the same as just A union B?
Okay. I heard 2 questions. I'm going to get your second. Repeat that again. I'm sorry, Jay.
Is the complement of A intersection B just the same as A union B?
A union B was A union B. They're not the same. Look at what A union B is. A union B, if we go back to the beginning, is 1, 2, 3, 4, 5, 6, 7. So they're not the same. But, Harrison, what were you going to say?
How is that one different from that one?
Would you remind me what was the complement of A union and complement of B? What was it? What was it? Read it to me.
3, 6, 7, 8, 9.
What do you think? That's called De Morgan's Law. De Morgan's
I said it's a complete
Law.
lie.
They will always be the same. And of course it is, because think about what this is saying. It's saying it's not in A and B, which means it's not in A or it's not in B, right? If it's not in both of them, we know it's not in both of them, then either it's not in A or it's not in B.
So, okay, maybe
So these have to be the same.
is it
They are not the same by symbols, but they're the same by answer.
Is that the line on the top, the one that goes all the way through?
Goes all the way
What's
through.
different than that one that A intersect B with just 2 little lines of A and B?
Okay, in this case, we just did what wasn't in A, we just did what wasn't in B, and then we took the union of them. Here, we took A intersection B, and then we did the complement of that. Okay? You can stop the video, Mark. I only got through number 1. I hope to get further